Hello and welcome back to Aggressive Mastery. This is GameDevMicah, Micah Berninghausen, and I'm going to be talking today about ways to reduce down draw calls using Nanite and Unreal Engine 5. Of course, the pros and cons of doing so. In front of us, we have a display that's dense with a lot of things going on. I'm going to briefly run through this example, and we will have this example up on GitHub, and you can grab that link from aggressivemastery.com. for you to go ahead and see a more intense example of using custom primitive data and per instance custom data to drive texture selection within a single material. It lets you have a unified nanite mesh with a single material on it, perhaps, or at least a reduced amount of materials on it. And those reduced amounts, since once you have a nanite mesh, the only draw calls are for each material, the less materials you have, the less draw calls you have, and so theoretically the less overhead you have to deal with. Now the pros and cons. The pros are less draw calls. That's sweet. The cons are the textures that you have in that material. It's going to be loaded and stored in your virtual memory, your VRAM on your card, and in the system memory too. So you're going to have a cost for the textures. If you don't use the textures in your scene or in the view, then traditionally in standard rendering, Unreal would get rid of them so that free up that memory. But we're not going to, because we're going to keep that texture always loaded for the other instances that are using the right textures out of it. In this scene, I'm showing an example of it, which is that we have red, blue, green, just colors on the right. So all these meshes on the right are actually static meshes. If we go out in the view, these are static nanite meshes, and you can see when they change their color, they'll change their material ID. And that means they're going to have a collection of like 9 different draw calls. On the left is all a single material, and what happens there is we're changing the, and it's a nanite mesh as well, just static mesh components. As they change, they're staying the same material ID because we're just changing the data, the custom primitive data on the component. We can also do this with ISMs being driven by the per instance custom data, and we'll go through all that in this little demonstration and tutorial that we'll look at now. All right, so we'll just make a material. This one's going to be a custom data driven material. Let's go ahead and open it up. And here, what I want to do is take a input of a float. And now with this value, if we ran it into the base color, we set it to 1, you get all white because all the values are being expressed as the base color. And so your ball is white. So what we can do is we can convert this into a parameter so that then we can change it. So we'll say our custom index. I'm calling this a texture index now, well, even though it's just a value. And then we can come down here and click this little spot that says use custom primitive data. And this would be for when you're doing anything that's using a single component, like a static mesh component, anything that's not instanced, because we do have the option to use per instance data, and we'll show that one next. But so if you're using standard primitive components, you use custom primitive data. So we have that done. We now have our custom texture index as using custom primitive data in this material driving the base color. We'll just use the cube. All right. We'll come in on this cube. We have a default material to assign. We'll come out here and we'll assign it to this material that we just made. Boom. Now our cube has been assigned. Now let's go ahead and grab a mesh. Now what you're going to see once we assign this material, since this material has a custom texture index assigned being attached to a primitive data here, since we've done this little checkbox, and let's bring the cube into the world. There it is. Now we don't have a light in the world, just to save that cost. Let's go ahead and we'll make the texture emissive. And let's change this. So now we have our static mesh component with the assigned mesh that has a custom primitive data. Close these out, get to rendering, there we go. And now we have this new area here, custom primitive data defaults. We open that up, there's one right here, custom texture index. So it pulls that out of the material, and now we can change it. Let's make some more of these. So now we've brought 3 static meshes in, and you can see on each one of those they have their own individual custom texture index. So this one is 0. And now we have the different colors. Make sure you enable Nanite. Ba-ding! Now save all that. We're Nanite enabled, and we can put as many as we want now. And they will just be the same draw call. You can modify the texture to be whatever texture you want too. Now of course we're passing in colors, so you can put whatever color you want. The real piece is when we start to go to textures and setting, different detailed materials. So instead of doing nothing except for color, we can run this into an if statement. And after that if statement, we'll do the same thing. So we'll say if it's 0. Let's go ahead and grab some textures. We got our 3 textures here. Boom, 1 texture, 2, 3 textures. So now we got 3 textures. That this would have been 3 separate materials. If it's equal to that or less, we'll take this guy. If it's more, we'll do another one. Bring it down here, connect this into the if it's greater than 0. This one will say 1. Bring A in from our custom primitive index again. We'll run this guy into the if it's equal to or less than, and then we'll do another if for the last texture in here. So we can do it like this. 0, 1, 2. So now if we send in a 0, we're getting green. We send in a 1, we're getting red. And if we send in anything greater or equal to a 2, we get the bullseye. And we can change it. Ta-da! So now we have different textures across the same material. And so 1 draw call. Up these 3 materials and make sure they have some emissive. Since we don't have any light in the scene. I just edit the static mesh components. I think I'm just going to do something. You're this guy. Oops. You guys down here, this guy. And then you guys. Save everything. Come back out here. Oh, look at our different materials. It's kind of fun to see. So now, this level, we have different materials. And then the mesh is still Nanite. So we're getting more draw calls. And let's compare the two. You see we got 2 versus 4 base pass. By burying things into the textures, or the textures in the same material, you can reduce your draw calls, but you're going to have that extra data of all those materials you're passing. So you want to make sure that if you do this, you do it for things that are just always going to be on screen, or mostly going to be on screen. So if we wanted to do instant static meshes instead of static meshes, well, we want to convert these into ISMs. So what we need to do is just select them all, make a pack level actor. I like world origin. That way we can always place it where it's supposed to go. So we'll say packed level Asks to say where the blueprint is, and boom, there's our pack level cubes. Now you notice that they are all green because the material we're using on them is now an instant static mesh. We can go ahead and open up this blueprint. There's our new ISM it created for us. Make a copy of this since we need an ISM version of it. Duplicate, and I'm going to say in here it's going to be a, instead of a custom data driven, it's going to be a per instance data driven. Per instance custom data driven. And that's going to be the one we want to assign to the ISM. So we'll come back into the blueprint, boom, put it on the ISM. Still not working, right? Because we're going to use per instance data. There's our instances. We have 216 instances, that's a lot. And you have this custom primitive data here, 0. So if we, and then we have 1. This is the actually the custom texture index for the custom primitive defaults. Oh, we don't want to mess with this. We want to mess with these. So you'll have both of these. This is the actual component, so the ISM itself, where then the custom data here is for every individual instance. And it looks like we did save the value actually. That's really useful to know. It automatically converted the custom data on the primitives over to per instance custom data on the ISM. That's so nice to know. But we're not accessing it because the material doesn't know how to. So we're going to go back to the material that we just copied, that we want to apply here, the per instance custom material. And we're just going to grab a different thing. So we're going to grab per instance custom data. First one here, per instance custom data, is an int. Whoop. Plug it in there, hit apply, hit save, head on back, and guess what? It should work. There they are. It changed. Now we got the original configuration back. And of course, if we wanted to see about what I mean original configuration, we could just actually run this straight into here, and we'll get the gray, white, and yellow, black back. Boom. And this one here is where we have extra draw calls because we have only 1, 2, 3 materials assigned. So we have 3 materials. So we hit F8, we go show, we go Nanite material ID. So each Nanite plus these different colors would be our draw totals. And so if I change the level, boom, one draw, 1, 2, 3 draws, 1 draw, 1 draw, 3 draws. So base pass 5, or base pass 4, 2, 2. So you can see that we've saved 2 draw calls. Now it's just 2 draw calls because I haven't done more. So let's actually go look at a level where I've done more. These, there's only 6 textures used over here. We're cycling through 6 of them. But we have all these colored ones in there too. Plus we have more textures over here. Hide these, it's 11 draw calls, 9 total textures or materials at the base pass. Here's 10, so we get 1 extra. If we hide them all, you can see we just 1 base pass for all these. So 0, 1, 10. 1, 0, 9. 9 materials. So, and we can unify this into here. So if we took this guy and put his material index up to 20, hit play, there's yellow, so he gets action to all the colors in the material, which includes these. Once he goes above 9, so 9 through 17 would be colors. Or you could pass in, you know, these variables right through their own float and set the colors like per value. So you can not just need to send in an integer to do this, you can send in many other things, but the example is just with the integer. So now you got the basics. from starting from scratch, making the material, looking at how we can unify textures into a single material, drive texture selection using custom primitive data or per instance data off of ISMs or instance components, and then have a single draw call for materials, and also knowing that we should use materials only that we know we're going to be seeing. So buildings that are always repeatedly used, landscapes, or if you're doing a red versus blue, red and blue, probably good examples of materials that you could combine. So you could have a red material and you could have a blue material, and that would still, and those would be combined red and blue materials. That would still allow Unreal to unload the red material if it doesn't see it. But when it does load it would load all of them. Then you should really use red on all those static meshes, that instead of having custom red textures for every single mesh. See what you can reuse. Maybe put in logic or code to make the textures look unique for the static meshes instead of being new, different textures. And then here's an example, is if we look at, this is the same material on the back here, we're not using our RGB materials. And so if we were looking at just these pieces here, except for that one sphere, so if we look at them like this, there's no RGB materials in use, so all the RGB material space in VRAM would be wasted. Or then if we look over here, we now need it because we have those colors on screen. And if we go and turn off all the static mesh components that are using non-unified or using non-unified materials, so now we're just dealing with a unified material, we get a single draw call, which is for all 17 of these textures. And if we turn them off, we get 9 draw calls for the static meshes that are using 9 different materials, but they are Nanite. So it's all about doing the unification of materials, and it really means unification of texture memory, and it's really about how do you keep and how do you judge if a texture is rendered on screen or not. Do you let Unreal do it, or are you helping Unreal out and telling it that it's being used, which is what we're doing here. We're trying to help Unreal by having it not have to consider if these textures should be streamed in or out, and just it knows it has to render that material. And so that's the savings that we're doing here. So say you have 200 draw calls on your one Nanite mesh. That would be 200 textures, 200 separate materials that you're having on that get merged together in that one mesh. If you were to put all 200 of those textures into one material, there's probably some of those that are not being seen at different points in the game. If it's a lot of time between when they're seen, then it's a lot of space in the memory you could free up for other things that are being seen, that are brought in, that are not in that material. All right, thank you for checking this out. I look forward to seeing you at Unreal Fest in Orlando if you're going. I'm giving 2 talks there. My first talk's going to be focused mostly on Fortnite and static level optimizations. I'm going to be talking about using instant static meshes, data layers, the draw distances, and reducing them. Typical optimization things to help improve level design and how it runs. Turning off collisions, turning off shadows. Check that video out. It should be streamed on the Unreal YouTube platform and everywhere else they're at. And then I'm also giving another talk. It's called Speeding Up Destruction with the Giantess Playground. That's where I'm going to be talking about integrating my destruction program using Nanite, Niagara, and a whole bunch of other tricks with chaos to destroy the Matrix Awakens small city with a giantess, or really giant lady. And you can check that all out on aggressivemastery.com. Thank you. Bye-bye.